Hello everybody, this is the first of 6 presentations talking about geology and settings and information about critical raw materials from a variety of different settings. This will be hopefully about 12 minutes long with a little time afterwards for questions, but not too many if we could keep to a time scale. So I'd like to start off with Cornwall and crystalline fractured rock that we have there. And this isn't just me, it's a whole kind of gang of people at the bottom there listed. A lot of contributors from work package 2 is within this project, CRM-geothermal. So just a quick bit on geology first. Where are we? We're talking about southwest England. The Veriska and orogeny introduced several granites into basically a series of Devonian basins. And this was about 280 to 290 million years ago. And these drove deposition of your classical ore minerals, copper, tin, tungsten. Long history of mining in southwest England, very famous for it. In fact, the whole region is underpinned by a very large granolithic Nubian batholith, of which we see 5 different ones at the surface, big pieces of granite. Dartmoor, Bodmin, St Austell, the Land's End granite, and the Carmenellis granite. And 2 of these are associated with active geothermal exploration at the moment, one at United Downs, one at Eden, and there was also a project, a hot dry rock project in the 1980s. And they're there because the granite contains small amounts of potassium, uranium, thorium, gives off a tiny amount of heat, and gives it higher geothermal gradient. And that's why these hotter rocks at shallow depths. In terms of what we're looking at, it's fracture zones within the granite. So on the left-hand image, that's the very, very tip of Cornwall, where there are the green lines, you can hopefully see, are the fractures. They trend roughly north-northwest to south-southeast. There's many of them. These are long-lived, multi-kilometre long fractures. And it's those that are geothermal targets. And one of the models is that there are potentially within the plane of each of those fractures, hydrothermal circulation cells set up. One on the top right, on the right-hand side there, there's downwelling fluids, travels at depth, several kilometres, picking up elements such as lithium, and then maybe where there are fractures or higher zones of higher permeability, rising fluids that are warm, and then it brings these critical raw materials as a result closer to the surface, and heat, and then a circulation loop within that sort of system, returning the fluids back to depth. And if you drill a borehole in this upwelling zone, or you sink a mine shaft if you're after mining, you might get warm springs or warmer temperatures in your geothermal boreholes. And of course, rising hot water, that's better for exploration targets, more heat, more dissolved critical materials, perhaps lower risks in terms of project risks. So the deep groundwaters, we've looked at some of those within the CRM